For over half a century, the moon has been a graveyard of footprints and abandoned rover parts, a silent monument to a brief era of human daring. Since the departure of Apollo 17 in 1972, no human has set foot on another celestial body. But as we enter 2026, the silence is about to end. We are no longer talking about visiting the moon for a few days to plant a flag and collect rocks. We are talking about staying. This is the Artemis Mission the most ambitious international space project in history. Named after the twin sister of Apollo and the Greek goddess of the moon, Artemis is not just a sequel to the 1960s space race. It is the construction of a permanent human presence on the lunar surface. We are building the foundations of the first lunar city, turning our silver neighbor into a thriving industrial hub and the ultimate stepping stone to Mars. The primary difference between the Apollo missions of the past and the Artemis missions of today is sustainability. Apollo was a sprint, a high-stakes political race to prove technological superiority. Artemis is a marathon. The goal is to establish the Artemis Base Camp at the lunar South Pole. To do this, NASA and its international partners are building a multi-layered infrastructure that includes the most powerful rocket ever built, the Space Launch System, a new crew capsule, Orion, and a modular space station that will orbit the moon, known as the Lunar Gateway The gateway is perhaps the most critical piece of the puzzle. Unlike the International Space Station, which orbits Earth, the gateway will stay in a near-rectilinear halo orbit around the moon. It will act as a command center, a laboratory, and a changing station for astronauts. From the gateway, crews will board landing craft to descend to the surface and return, creating a reliable ferry system between the moon and deep space. It is the front door to the lunar city. Why are we heading to the South Pole? For the Apollo astronauts, the equatorial regions were easier to reach and land on. But for a permanent city, the South Pole is the only place that makes sense. It is home to a unique geological phenomena. The peaks of eternal light, and the craters of eternal darkness, Because of the moon's slight tilt, certain mountain peaks at the South Pole are in near constant sunlight. This provides an inexhaustible source of solar energy to power a city. Just a few miles away inside the deep craters where the sun has not shone for billions of years, temperatures are colder than the surface of Pluto. These cold traps are the most valuable real estate in the solar system because they contain water ice. A city on the moon cannot survive if every drop of water and every breath of air has to be shipped from Earth at a cost of thousands of dollars per pound. To be sustainable, the lunar city must practice in situ resource utilization, ISRU. This is the science of living off the land. The water ice found in the South Pole craters is the gold of the 21st century. It can be melted for drinking water and used to grow food in lunar greenhouses. But even more importantly, water can be split into hydrogen and oxygen. Liquid oxygen and liquid hydrogen are the primary ingredients for rocket fuel. By mining the moon, we are essentially building a cosmic gas station. Spacecraft headed for Mars or the asteroid belt won't have to carry all their fuel from Earth's heavy gravity. They can refuel at the moon, making deep space travel vastly cheaper and more efficient. How do you build a city on a world with no atmosphere, extreme temperature swings, and constant radiation? You don't bring bricks from Earth. You use the moon itself. The lunar surface is covered in regolith, a fine, jagged dust created by billions of years of meteorite impacts. NASA is collaborating with companies like Icon to develop large-scale 3D printing technology that uses lunar regolith as ink. Robotic printers will land on the moon and autonomously build landing pads, roads, and habitats. By mixing regolith with a binding agent or using lasers to sinter it into a solid ceramic, we can create structures that are incredibly strong. These habitats will likely be covered by several meters of raw regolith to protect the inhabitants. On the moon, the sun's radiation and the constant rain of micrometeorites are lethal. A city on the moon might look more like a series of buried domes or interconnected tunnels, using the moon's own soil as a natural shield. Some architects even propose building inside lunar lava tubes, massive underground caverns left over from ancient volcanic activity, which could house entire neighborhoods in a temperature-stable, protected environment. To get humans and heavy equipment to the surface, NASA has turned to the private sector, specifically SpaceX's Starship Human Landing System, HLS**. Starship is a gargantuan vehicle, far larger than any previous lunar lander. It is designed to be fully reusable, capable of carrying 100 tons of cargo or dozens of passengers at a time. In the Artemis 3 and 4 missions, Starship will act as the elevator between the gateway and the lunar surface. Its massive internal volume will serve as a temporary base of operations for the first pioneers. The sheer scale of Starship is what makes a city possible. If Apollo was like taking a small rowboat to a new island, Starship is like a massive cargo ship, capable of delivering the heavy machinery, solar arrays, and life support systems needed for a permanent colony. Living on the moon will be a profound psychological and physical challenge. The moon has only **1/6 of Earth's gravity **. While this makes for fun acrobatics, it also causes the human body to change. Muscles atrophy and bones lose density. Residents of the lunar city will have to follow strict exercise regimens to stay healthy. Then there is the lunar day. Most of the moon experiences 2 weeks of daylight followed by 2 weeks of night. At the South Pole, this is slightly different, but the rhythm of life will still be dictated by the harsh environment. To prevent the Earth sickness or isolation that comes with living 240,000 miles away, lunar habitats will be designed with artificial nature hydroponic gardens that provide fresh food and a sense of green life in a gray world. These greenhouses won't just be for food. They will be the lungs of the city, recycling carbon dioxide into breathable oxygen. Why build a city at all? Is it just for scientists? While the initial inhabitants will be researchers, the long-term allure of Artemis is the creation of a lunar economy ***. Beyond water ice, the moon is rich in helium-3 ***, a rare isotope that could be the perfect fuel for future nuclear fusion reactors on Earth. Just a few shuttle loads of helium-3 could theoretically power the entire planet for a year. The moon also offers a unique vantage point for science. The far side of the moon is the quietest place in the solar system, shielded from the radio noise of Earth. A radio telescope built there would be able to hear the very first stars of the universe, discoveries that are impossible from our noisy home planet. Furthermore, the moon will become a destination for space tourism ***. In the coming decades, the city may include hotels for those wealthy enough to want to see an Earthrise with their own eyes. As we look at the calendar, the Artemis missions are moving fast. Artemis 2 scheduled for 2025 to 2026, will carry 4 astronauts, including the first woman and the first person of color, on a trip around the moon. This will be the first time humans have left low Earth orbit in over 50 years. Shortly after, Artemis 3 will attempt the historic landing at the South Pole. By 2030, the goal is to have the first foundational pieces of the Artemis base camp in place. This will include a power grid, a communications array, Lunar net, and a pressurized rover that allows astronauts to travel miles across the surface in shirt-sleeve comfort. This is the transition point where a mission becomes a settlement. Ultimately, the city on the moon is a rehearsal. NASA calls it Moon to Mars. Everything we learn on the moon, how to mine water, how to shield against radiation, how to maintain 3D printed habitats, is a skill we will need for the much longer journey to the red planet. The moon is only 3 days away. If something goes wrong, we can come home. Mars is a 6 to 9 month journey. We use the moon to fail, to learn, and to master the art of extraterrestrial living so that when we finally send humans to Mars, we know they can survive. Building a city on the moon is the greatest engineering challenge of the 21st century. It is a project that unites nations and private companies in a shared vision of the future. It represents our transition from a planetary species to a spacefaring one. The Artemis mission is the bridge between the world we know and the universe we have only dreamed of. As we look up at the moon tonight, we should see it not as a dead, gray rock, but as a new world. In just a few years, there will be lights on that surface, not just the reflection of the sun, but the glow of human windows. The city on the moon will be a testament to our curiosity, our resilience, and our refusal to be bound by the gravity of our birth. We are going back to the moon, but this time we are staying. And from that small silver foothold, the rest of the stars will finally be within our reach.